Welkom bij de podcast van Menno en Erwin. Ja, en dit is de laatste aflevering van onze speciale summer sessie. Ja, Menno, dus we gaan zo meteen weer Engels praten volgens mij.
Ja, we gaan weer Engels praten met Bill. En waar ik het over wil hebben, dat is dat ik ken Bill omdat hij heel beroemd werk gedaan heeft aan de biologische klok. Hij heeft de energieuitgaves van de biologische klok in kaart gebracht. Daar heeft hij het veld enorm mee opgeschud. En de rol van de centrale klok in onze hersenen heeft hij heel veel werk aan gedaan. Daar is hij behoorlijk beroemd door. Mm-hmm. En dan op een gegeven moment dacht ik, god, wat is eigenlijk de achtergrond van deze onderzoeker? Hij zal toch niet bioloog zijn, dat moet toch eigenlijk wel. Maar hij is helemaal geen bioloog, hij is een medicus, dat is natuurlijk al wat. Maar dan is hij ook nog zenuwendokter, zou ik maar zeggen.
Ja.
Neuroloog, als je het netjes vertelt.
Ja, dat vind jij lastig.
En nou wil ik eigenlijk toch wel eens weten, ja, wat is nou die connectie die hij zelf gemaakt heeft, the connection between neurology and your work on the biological clock. Is there any, are you living in two split worlds, separate worlds? How is this for you, Bill?
They really were separate worlds when I was engaged in them, although they've come together now.
So, let me start first a question. Menno, sorry, I interrupt. Why did you get involved in clocks, internal clocks? How did you like it, or how did it field come up?
I'll have to start early, sort of early. Although I will say in support of this, in terms of neurology and clocks, when I was actively working on some of these experiments, there really was only one other neurologist who was interested in clocks. Perhaps it was weird, although it isn't now. I guess I would start in high school in figuring out what I was interested in doing.
Girls.
No. I was very studious, studious. Okay. But in the United States, they always say, do what you're passionate about. Follow your passion, which I found difficult to actually accomplish. Although I always felt pretty passionate about what I didn't want to do, so I worked that way. And I enjoyed the subjects in school. I was a strong student. Language I was not that interested in. Math was not natural for me. History I enjoyed. Art I enjoyed, I suppose. In terms of literature, where we wrote long essays about what the writer intended, you couldn't refute it. It would be nice to pose a question and be able to disprove it. And biology, as a science, living things moving around, they were very complicated. Physiological, that's a complicated system, but PhD, what would I get? What would I choose? And of course, the beauty of the U.S. system is you can go to university and you don't have to declare anything. You can get what would be called a liberal arts education. And so I did that. I majored in biology and I learned about biology. Again, there was no specialty that I was going for. So, as you know, we do 4 years of baccalaureate and then 4 years of medical school. And, medical school in a way, although it's superficial, doesn't dig deep, it's broad. And all about living systems, the human condition, full of human stories. If you do it right, you can even help some people along the way. And so that seemed like a good open education. And during that time, I did a summer project, research project, and I discovered something. It was a little on a electron microscopic view. It was a little anatomical thing in the eye, and I published it. And a discovery of something that nobody had ever seen before. Gee, that's like the Dutch, heading to Indonesia. It's like Vasco da Gama. It's like space. Things that people had never seen before.
Yeah.
And in the U.S. system, the idea that an academic MD would be seeing patients, teaching students and residents about patients, and have a lab is not a foreign concept. And the person would have to be responsible for generating grant support and so forth. But it was even expected that the academic in the university, medical school, doc would be doing, international class research, basic or clinical, that type.
So how did you come to the clock then?
Right. So as I was finishing medical school and decided that I was going to do research, it was going to be in neuroscience. I was so scared that I didn't know enough neuroscience that I did a lot of reading. And this was in the early 1970s. And in the big books I read, there was a section on internal clocks, which had just started to sort of arise. And there were some basic biological chapters, and then some hints about, well, maybe there was a clock that was actually localizable in a place that you could cut it out and put it on the table, and it would keep going. And in the area of the brain called the hypothalamus, deep in the brain, which is responsible for basic things like appetite and sex and sleep and sympathetic and parasympathetic systems. So then I went off after some basic medical training to the National Institutes of Health, and I made a discovery using a new technique that I was hooked. Okay, so now I have a problem. I have an MD. I don't have a PhD. Now, MD, PhDs are popular, but at that time it was not
so important.
So it was usually you went to medical school, then the National Institutes of Health, and then a faculty position. And so I decided, well, of medicine, since I was interested about the clock in the brain, I would be a neurologist.
So is it then correct if I say that you were in your 20s and you find out about the clock?
Yes.
And then it took your whole career?
Yes.
And it's the same for Menno?
Yeah, so maybe 20. Well, that paper of that discovery I was 27.
Yeah.
And so then for 40 years.
And the rest of your time you worked in that area.
And this area is 1 millimeter long. And in the course of this, I had to learn all sorts of techniques and approaches. So I was a student to be able to probe this. A very wealthy friend who we had dinner once with, retired when he was in 50, now builds electric cars and for fun and so forth. And he asked what I was doing, and I described it, and he asked me, well, if you're working in the evening, say writing a paper or reading papers or thinking or something, how do you charge the grant? Do you do time and a half or something? And then I had to say, well, I think the way to think about this is I'm more like an artist than anything else. And so I had, for those years, the combination of both being a neurologist and having a lab doing the clockworks. And the part that was unusual was that, generally speaking, more so now, if you were a neurologist, your research was really directed to something very disease-related, you'd work on epilepsy or stroke or multiple sclerosis or brain trauma. And I was working on something
fundamental.
that was fundamental and very far away from applications. And my colleagues and friends were working on fruit flies and bacteria and mold and so forth.
To interrupt you, the reassuring thing for me is that the starting was laid in a biology education, very reassuring for me and confirming my idea that biology is central in life. And then also a little bit new for me is that you were guided to the biological clock, as I was as a bachelor student, by a textbook, a small textbook with a question mark in the brain of a rat with the underscript clock, question mark, and the chronology book. That put me on it, but it took me many more years, and I have never become in any way so famous as you have become. But now, and you described very beautifully that you could do your clockwork, and you worked as a neurologist, basically in a clinical session, in a clinical environment, and that were still rather separate worlds then.
They were very separate in the way that people think about it now, but in terms of the activity, which was, how do you solve an unknown, right? How do you? What if you don't know what the patient has? Yeah. Okay, if you know what the patient has, then they have sheets of things to follow. Yeah. What if you don't know what they have? What do you do? How do you approach it? Yeah. Well, it's the same as the other unknowns. And I must say, unhappily, that those of us who were neurologists who were interested and who had basic science experience were told by the trainees that we approached the patients somewhat differently. And we approached it, what's the first thing? Well, you have to take the history first. And generate hypotheses, which means you ask different questions depending upon what's going on. And then the examination is an experiment to actually refute some of your hypotheses. Yeah. And that's the way that you can, I would say, effectively and efficiently know, well, what test should I order? What am I not worried about? And so in a intellectual way, they actually were the same.
But was it then different from the classical neurological approach where you had your catalog of diseases and, well, the best remedium we know is this, so let's apply that? So just going by the list, is that...
It was a modified, so it was a hypothesis driven. Yeah. So you had a list of the things that you thought were most likely based on an argument of reason that you could make. Then that was supplemented with a list with two other lists, which were short, which is, what's the most dangerous thing this could be, even if it's unusual. Yeah. And related to that, what is it that I don't want to miss? And so it's the combination of those pieces, as opposed to write a template of diseases. Yeah. And
so it's more, for me, it's more sounds like the Dr. House approach of those who are aware of this series. Yeah, he is always asking this type of questions. Well, and it's relating, what is the worst case scenario? Well, this could be, how do we avoid, how do we know? Yeah, that's this approach. But it's against this protocol-like
yes, the protocols are great if you know what the patient has. Yeah. Then you don't skip anything, you do it in the right order, it's done standardized. I mean, you better be pretty sure you know what the patient has. Yeah. But what if you at some point you won't know?
Yeah. This is the greatest Dutch philosopher is Johan Cruyff, who say, if you know the solution, it's very simple.
Yeah. Yeah. But I'm sitting here with two experts in the field of clocks and internal clocks, etc., etc. And I'm very curious, so where do we go from here? I mean, if you look at the future, we have massive AI coming in, maybe, could be interesting in this field also, or
Massive.
artificial intelligence, for instance.
Yeah.
There's breakthroughs with that kind of things. Could be. If you look at your field of expertise, do you have any idea where will be the next steps or something?
Well, the first thing to be a little bit more nice towards Bill is that I see nowadays the many connections between biological clock systems and neurological problems, because obviously there are many clock aspects in many of those. There is many time aspects in many neurological problems. So there will be connections. And now your most difficult questions about your favorite topic of AI and connection to
I don't want
neurology.
to talk about.
But
sorry, man.
What do you see? What do you think about that? Are there perspectives?
Yeah, I don't. I'm still on the fence with AI. I think it's like we have navigation systems, we have spell check, we have all of these.
Yeah.
This one seems to arouse more dismay because it has to do with writing. But those were all brain functions, spelling and navigation. And the one thing, for me anyway, that those have in common is, number one, they don't absolve you from checking.
No, definitely not.
So, spell check, okay, spell check, but you still have to proofread. Navigation systems, if you know something, you know to reject perhaps one of those solutions. So I think it's all in a matter of knowing something to begin, and then perhaps asking the question to the AI robot in a certain way or the right way, or checking. So I don't think it absolves us like a Tesla automatic driving that doesn't work. So we need to remain in command.
Yeah, that's true.
But in terms of the science of clocks,
what I was more because you're both two experts on the field of clocks, internal clocks and sets. I was wondering if you could. What do you think? What do you think in 2-3 years in this area? So nothing about artificial intelligence, but what do you think?
So one is the one that sort of focuses on Menno's point, and that is applications. So now we know something about mechanism and the gears and the working. We still need to know more, but now all sorts of ideas relate to applications. For example, the importance of light, natural daylight, for lighting designers, for urban architects. What happens for people who live in apartment blocks with no light? In the United States, there are some real estate developers who are trying to build buildings without outside windows. What does that mean? I know Europe is way ahead on that.
Yeah.
So applications to medicine as well. And so there are interesting associations with disorders where sleep or clock function seems to be off from normal. The big challenge on these kind of things is to know whether the clock has been remodeled as a kind of guard against, as a kind of adaptation to the disease, or whether it's actually causing more trouble.
You don't know the chicken of egg.
Okay. Right. So so a very simple sort of, because the body is always making adjustments, right? We know that from drugs, that work for a while and then don't, because the body has changed its reaction. So there's all of that. And then what I think is really exciting is to put the clock now in its natural, challenging environment. So we've seen how it works under a very controlled arena in the laboratory. Everything is set. Now let's put it out in the world, where we've always been saying it's been important for adaptation to all sorts of challenges. And again, as we said in a previous podcast, we have portable wearables, and we can really see how things are working in the field.
So you see this is as the breakthrough now, that from till now you studied everything in the lab about clocks, and now you have to study it in the open field.
Well, and now we have the tools that we could, the circadian people can rejoin the ecologists, with whom we were once twins, and bring it out to the field in real biological problems, and to show the variety and the diversity of solutions that plants and animals have to deal with trouble, including light pollution, climate change, those things that are important.
Right. Well, do you have something to add? What do you think?
Well, it's basically a topic where Bill and I have, we're working together. We organized some meetings between ecologists and chronobiologists, people who study the clock. So to get them together to combine these formal and theoretical and physiological knowledge together with the field people, so to confront it with real conditions. But still, the other thing is that we have to be open for new technology. We just had the podcast on von Leeuwenhoek and the meaningfulness of his small loop, which gave us a completely new view on life. Still, we detect systems, how we can look at life in another dimension. And I'm especially interested in tracking fast rhythms, because I think that's an important aspect that is still part of the deal, and we neglected it just because of technical problems. And then in the ideal situation, you can combine both. So go in the field and have this new technology also in this detail of fast rhythmicity detected in a field situation. There we really get at new insights, because the idea that we know now the biological clock system, well, I feel it's nonsense.
Well,
I don't know how you think about that.
Well,
Bill?
Everything is always emerging, right?
Yeah.
Always with new ideas and so on. But we've got some stuff to work with.
So you see immediately this blunt Dutch answer that it's nonsense, and he's saying politely,
Okay. Well, guys, thank you very much for this podcast. Bill, it was a great pleasure having you here, and I hope if you travel again to the Netherlands that you join us in our next episode.
Would love to. Thank you for the invitation.
That's great. And what I have learned from all the podcasts with Menno is that the more we know, the less we know. So, this is the end of our special summer edition of our podcast Menno en Erwin. Ja, we gaan weer terug naar Nederland. Maar vond je het nou leuk? Dit is een beroemde wetenschapper, Bill Schwartz. En we hebben het over verschillende dingen gehad. Vond je het nou leuk? Ga naar onze website www.mennoenerwin.nl en geef je dan even op voor de nieuwsbrief. Dat vinden we leuk. Dan kunnen we met je praten. En dan krijg je elke week nieuwe weetjes in je e-mailbox.